Hello, this is Zining. I'm very glad to be here. I've been in U of T and Vector for the past few years, and I'm currently waiting for the visa, actually. We'll go to the New Jersey in a few months. And today I will be very happy to present some of the works that I've been recently working on, mostly centering around the explanations and how the explanation will play a role in the future collaborations between humans and AIs. So this is a search box that perhaps many of us are already familiar with. This is the entry point of perplexity.ai. Recently, this has become one of my favorite search engines because compared to other search engines, perplexity.ai can give us some detailed explanations of the answers, as well as some links towards the sources that leads to these answers. This is another tool. Perhaps many of us has already plugged in the GitHub Copilot into our editors. And the screenshots are taken from the GitHub Copilot's official website. There are some functionalities. We can prompt the model behind the Copilot to write some code for us. We can also provide the codes to them and let it write some unit tests for us. There are several other things that GitHub Copilots are able to do. So this kind of generative AI tools are making our work and lives a lot faster than before. There is a common pattern behind this kind of work. We are gradually using the generative AI technologies as an assistant that is working together with us. We as humans give the AIs instructions and we get their reports back. Among their reports, there are several common components. For example, we are letting the AIs to present us with some result. And of course, there is the traditional use case of letting the AIs predict some outcomes. Traditionally, AIs are used as prediction machines. And in recent years, we are using generative AIs, for example, the large language models, to create some artifacts. So in each of these scenarios, we will have some corresponding concerns about the report. If we are asking the models to present us some result, we will naturally question their chain of thought. How did you arrive at this result? And whether these AIs follow our instructions correctly. We will want some explanations that attend to these kind of questions. Similarly, if we want those AIs to predict some outcomes, we will want some support of those predictions, and perhaps we would like to know some alternate outcomes. And ideally, we would like to see some decision tree, something like the tree of thoughts inside the AI's report. In this way, the predicted outcomes will be supported by will be supported well. And similar concerns takes place when we are asking those AIs to create some artifacts. For example, are there some potential effects, negative effects of those generated texts? Are there some IP infringement issues or privacy issues? We will want some explanations from those generative AI tools. So we have, up to now, hopefully I have convinced you that explanation is going to be a very important part if we are working together with those AI assistants in the future. What is explanation exactly? I copied a definition from the psychology dictionary online. It states that explanation is the account of providing meaning for an event or phenomenon. Meaning is something that happens in our mind. An event or phenomenon is something that we want some explanation of. So the event or phenomenon can be a problem. It can be some descriptions of something that happens just now. For example, we can say the sky turns dark, and one account that can provide a meaning for the sky becomes dark is because the sun has gone down. So there are many things an explanation can do. For example, they can rationalize a problem after this problem is presented to us. On this screen shows an example of the natural language inference problem. In the natural language inference problem, we are presented with two sentences, A and B. These two sentences could be contradictory, it could be neutral, they could be intelligent, and we are presenting it with an answer label. And in this example, the answer is contradictory. So on the first side, this answer might not be very reasonable. It might be not that obvious if you only have 1 second to read through the 5 lines in the problem. But here, what if we are also presented with an explanation stating that because long is contradictory to short, and the two sentences are actually describing contradictory content. After presented with explanations of this kind, usually people will consider that the answer that describes the relations between the two sentences are more reasonable. Additionally, explanation can also provide us with some context that help us bridge the chain of thoughts from the common sense to the observations. This is an example from the another commonly used data set in NLP. When I hold a metal mark near the flame, my hands feel burnt. And one of the possible explanations is that because the metal is highly conductive of heat, and when you hold the mark near a flame, the heat is conducted rapidly to your hand, making your hand feel burnt. So this piece of natural language explanations connects the common sense to the effect and provides some additional context that extends beyond the descriptions of just the first line. So additionally, explanations can affect the perceived likelihood. Sometimes we see some results or the problems or the phenomena that are not that reasonable. For example, when we are searching for a product, sometimes the complementary product is returned in the list. You have probably already seen that on the search engine, especially in the product search many times. And this is actually has been one of the headaches of my colleagues when I was interning in Amazon in 2022 summer. And in one of the internship projects, we found that when we provide the users with some additional explanations, the perceived likelihood of the search result for those complementary products can be greatly improved. This is what the natural language explanation contains. It describes some details for the product. It describes the local regulations, and it also describes some relations of the search result term with the search query term. So in this way, the explanations can affect the perceived likelihood of the problems. It can make those that seem less likely more likely. So when we are producing explanations, what should be the properties in a good explanation? The good explanation should be informative. They should provide sufficient information for us to understand the problem. And also, they should be relevant to the problem. And this kind of rationales are very vague, and we want to translate them into numerical terms that we can measure empirically. So this is one project, the goal of one of our recent projects. We formulate a structure called the communication channels, and this structure of framework can apply in any type of text-based explanation problems. For example, natural language explanations and rationales. So on this screen shows an example of the input and output of this problem. The problem contains a pair of sentences, and a label that describes the relations between the two sentences. When we provide an explanation that links the sentence pair and the label, this explanation, together with the sentence pair and the label, formulates a framework of communication channels. This contains two channels, one between the input sentence and the explanation, and another one between the explanation and the label. So what is the benefit of formulating them into communication channels? The reason why we want to do that is that this allows us to borrow some tools in the information theory that can allow us to quantify some terms. And two of the most important terms there are mutual information and the channel capacities. In this project, we are focusing on the mutual information, which is roughly, if we know one of those random variables, how much uncertainty about the other random variable is reduced. So in other words, the mutual information quantifies the amount of information transmitted via this channel. So we set up tools to quantify the mutual information between that are transmitted through each of these two channels. So let's briefly take a look at what these scores measure. The mutual information between the input sentences and the explanations are largely correlated to the lexicosemantic relevance scores. And depending on the actual embedding, about 40% of the variance of that score can be explained by the features in this lexicosemantic category. In the other channel, the channel between the explanation and the label, the score is is about something that is more than reasoning. Around 15% to 20% of the variance of that score could be explained by the reasoning category scores. And also around 10% of those scores could be explained by the lexicosemantic relevance scores. So the mutual information between the label and the explanation is about both the reasoning and the factors beyond reasoning. Another benefit of that communication channels framework is that this allows us to look at the trade-off between the two informativeness scores. We found that in many of those language models, there are some trade-offs between the mutual information between X and E and the information between E and Y. So the models are intrinsically trading off between the strategies of whether transmitting more information in the left branch or the right branch of the communication channels. But that also differs from the models. And further, we show that by looking at this kind of trade-off relations, we can interpret the strategies of those embeddings. Like, are those embeddings considering the class-based relationships, or are they really embedding the deep semantics of the text? So these are the details about the previous project. And now let's shift gears towards another project that states that a good explanation should be contextual. So we are following up on this seminal work by Tim Miller in 2017. This work has been cited more than 4,000 times. And they argued that the explanations in AI are intrinsically social. So the goal of these explanations are to present the decision mechanisms of those AI models towards real humans. And the explanations that are presented to humans are selected from a huge bunch of data. And they are contrasted, meaning that they should help humans understand what is the true mechanisms versus the bad mechanisms that happen inside the model to be explained. Here's an illustration showing that how natural language explanation is contextual. So this is one search query that we have seen in the slides before. We are searching for a product, and the search engine recommends a complementary product. Let's also imagine that there are multiple audiences. one of the audience is an AI engineer who is really detail oriented. In order to convince this audience, you should present with them with some detailed mechanisms about how the returned complementary product is suitable for the input query. On the right hand side, you see an audience who is a casual customer. He's not going to spend more than 1 second reading anything. So what if we present the same explanations towards either of these two customers? If we present them with a very long, very detailed explanations, then the detail-oriented AI engineer is going to be happy, but the casual customer is not going to spend more than 1 second reading the text, and it makes no effect to present this very long detailed explanation towards the casual audience. Vice versa, if we present a very short high-level explanation towards them, then the casual customer is going to be a lot more satisfied than the AI engineer who is detail-oriented. So we are presenting with them exactly the same explanations towards exactly the same question, but the effect is different. So hopefully up to now, I've convinced you that the effect of the explanation is dependent on the audience. And in this paper, we figure out some approaches to incorporate the descriptions of the scenarios of the audience into the generation process of the explanations. We have seen that large language models are able to explain a variety of problems. We just describe the problem, append them with a functional word because, and hopefully the language models are able to naturally follow up with this prompt and write the explanations. And in 2022, some people at AI University of Washington showed that the explanations generated by GPT-3 and some language models like that already had very, very high qualities. And their qualities in terms of fluency, syntactical correctness, and the formality, informativeness, these kind of scores are comparable or even better than the explanations written by the crowdsourced workers. In this project, we explore several ways to adapt the generated explanations by writing the descriptions of the situations into the prompt. So we can say that I care about the details, or we can say something like the sky is dark because in detail. So there are many ways to write the prompt. What is a suitable way to write this prompt? Recently, we explored some prompt writing techniques. So this is one of the techniques that has the most significant effect. There are two sides of this technique. On the positive side, we use complete sentences to elicit the explanations. We describe the problem, we describe the scenario, we simulate a situation where the user is communicating with the AI assistant. You are helpful assistant explaining the following question to the busy audience and problem. On the flip side, we just use the functional word because to elicit the explanations. So we found that this technique, writing full sentence, usually result in longer explanations that are more detailed, and usually they are more convincing, and they have higher acceptability than the explanations written without this technique applied. So there are also two other techniques. Interestingly, the second technique is exactly to simulate a human-to-human communication between the user and the AI models. And whether that technique takes effect depends on whether you apply other techniques. So only the technique 3, which is to write full sentence, has more consistent effect than other techniques. Also, we found that only those models that are larger or equal to around 20 billion parameters in the size are responsive to those situated prompts. Those smaller models, for example, those 7 billion or 3 billion or even GPT-2 can still sometimes generate high quality explanations, but empirically we found that they don't really respond well to the situated adaptations in the prompt. So these are something about a new project. We found that good explanation should be helpful. It should be faithful, which means that they should tell the correct reason. And also the explanation should be simulatable, which means that a human should be able to simulate or contemplate, think about the solution of this problem based on the explanation. But in a recent project that is led by Rohan, who is here, we found that the explanations can be helpful in an adversarial manner. So large language models can explain the problems, but the models can also explain the incorrect problems. So if with some suitable prompting method, we are able to let the models like GPT-4 provide us with some convincing explanation towards the incorrect label. So this is something that we found potentially dangerous in the large language models. And sadly, up to now, we found that there's no easy way to guard this type of adversarial attack, because essentially those models are just following our instructions. And if we are asking the models to explain a question in a post hoc manner, the models are intrinsically following our instructions and figuring out some chains of thoughts that connects the dots. So in the future, a lot more researches should be done in order to safeguard the models against this kind of adversarial prompts towards incorrect explanations. So today we discussed some properties of explanations. We want them to be informative, contextual, and helpful. And these are the areas that I consider to have a lot of improvement room in the future. And as a big picture, I believe that explanation is going to be widely used, and it will be a very important part in the human AI communication. And the generative AIs would be more useful tools than ever before for humans. Yeah, I will be happy to take questions if there's any.
So very interesting. I have a question about the last part, about the fact that you can make the model generate an explanation for the wrong answer. So related to that, do you think that any post hoc explanations could ever be faithful? I'm asking that also because as like when people explain their own decisions post hoc, we tend to like rationalize them, where maybe like the decisions are sometimes like more like emotional, or like we had other reasons that we don't want to admit to ourselves. So do you think our models can do that well or not?
Yeah, this is a really good question about whether if an explainer only has access to the output and the input, whether the model is able to produce the exact same chain of thought for as the model to be explained. I think no. Yeah, and in order to be faithful in the real sense, the explainer needs to have access to a white box model, like the activation patterns and the input and output of every single layers. But currently, I feel like those data are a lot more complicated than the language models can handle without significant training. So we're actually developing some tools that can make the GPTs behave similarly to a probe. So we give the intermediate signals of the models to be explained into the models, and hopefully the model would generate some sort of natural language explanation towards the neurons and the patterns and the circuit inside the models. But that is quite a complicated project, and I think there will also be a lot of improvement area along that direction. Thanks.
So it would seem to me that in order to provide reasonable explanations to a problem, that the model would essentially have to reason through the problem itself. And given that language models still struggle with reasoning, then my thinking is, how do we ensure that the explanations are informative, contextual, and helpful in that scenario? Like, is it possible to provide a reasonable explanation without having reason through the problem? Or how does that interact?
Yeah, if not nowadays the models are we are essentially asking the model to solve the problem at the same time as providing us with some explanations in some suitable form, and that is quite a complicated task for the model itself, because we are asking the model to do two things at once. And for those results that are perceived as high quality, the models are doing both of the things correctly. And sometimes the correctness comes from coincidentiality. So they are doing it correctly, but they are not doing that correctly in the correct way, because of the correct things. It can sometimes result from the fact that they have already seen the answer somewhere on the website. So because someone else that has discussed these problems online, for example, on the blog, provided the model with the chain of thoughts towards the correct answer. And those pieces of text are scraped by the dataset collectors, and these are fed into the models, and the models like pastiche the things together and presented us with a copy of that. So I think that is most likely what has happened up to now. And in the future, we should definitely provide the models with some more complicated reasoning tests, like the reasonings in that involve something that do not happen yet, or reasonings that involve some hypothetical data that definitely nobody has considered before. So in this way, can we really test the reasoning abilities of those models? So any other questions? Yeah.
I guess I had a related question, which is, and you were talking about you're talking viewing producing explanation for the wrong answer as being undesirable, but is that really a bug or is it a feature? So that's what I think. Is getting an explanation, because it seems like it's very closely related to counterfactual reasoning. Because, for example, if I were to tell a model, I was walking in a crosswalk and I got hit by a car, how is this possible? I wouldn't want the model to tell me, well, according to the law, the car, you have right of way. Therefore, what you told me is impossible, so I don't answer this question. I guess, my gut feeling is that that's actually desirable and or may, particularly if the model itself is mistaken somewhere. It seems more like what might be a better solution is for teaching the models to tell us, well, this doesn't seem consistent with what I know, but if I had to reason counterfactually, then blah, blah, blah. But I just want to get any thoughts on that, or do you think like, no, this is bad, shouldn't be doing this at all, or I just misunderstood and you weren't really taking that strong stance, it would just,
Yeah, this is a really, really great question. And currently I don't have a very good answer towards that. This is I think this is more of a philosophical debate about whether it is okay to provide us with some reasonings that leads to the incorrect answers. And it could be helpful for some educational perspective. Like, for example, when we're explaining 1 + 1, and we should explain why it does not equal to -2. So that is actually one of the scenarios that we found difficult to guardrail, because in order to sort of apply some guardrails towards this kind of explanations towards incorrect answers or incorrect problems, we should also justify that this is not a desired feature rather than a bug, and it's very tricky to draw a line between a feature and a bug, and sometimes this kind of line might not even exist. So Yeah, this is a really good point. I don't have a good question, or I don't have a definitive answer towards that.
Talk about personalized explanation.
Yeah, personalized explanation is I think this is something that is definitely useful, and I think Duolingo already has some sort of features applied to that. Like if the model detects that you already have a lot of knowledge about this the corresponding syntax. For example, you are pretty advanced in the course, then the model could directly evoke that kind of syntax rules. But if you are still early in the course, sometimes I feel like the Duolingo app just explains some problems to me in some primitive version. So I'm not sure about the mechanisms behind and whether they have applied this kind of personalization. But the personalization is definitely something that should be there in the future.